Hello, how's it going? Gennaro here, CEO of Coitech Solutions, and I'm going to be talking about memory forensics. Now, memory forensics, well, as we all know, it's a practice of gathering information, collecting data, reporting, documentation, and this can be done within memory, within mobile devices, within web. So, forensics itself, well, it's an umbrella, if you will. And we'll talk more about in the other modules, the breakdown of network forensics, mobile forensics, and others. Now, to understand memory forensics, we look at volatile versus non-volatile. We look at the aspects of how can we gather this information, especially if a computer was used in this crime or investigation, a security incident, and it was turned off. Well, we no longer have access to the volatile memory, right? Because these are processes that are in place in a moment. And when you turn that computer off, well, that volatile memory, unfortunately, it gets erased. It needs power to stay on. It's a big difference, when it comes to non-volatile. But it's very important because you can take and think of like let's say a virtual machine. And you're using VirtualBox, you can take a snapshot. That's essentially what we're trying to do. Take a snapshot of the actual activity, especially if it's on in operation, you have that ability to do so. So with the techniques that are utilized with this, and a few do's and don'ts as well too. Because when we want to see what's happening in memory in real time, we have to capture it without altering it. I mentioned a term earlier, which is a write blocker. You have the ability to stop writing to the actual disk, which makes changes. So a few ways, right? Code boot attack. Now, this extracts memory content by powering off and then accessing the hardware aspect of it, but this is rarely ever used. More so, you see live acquisition and static, but we're talking about live now. So with our live acquisition, this is going to require those different tools like FTK Imager, WinPMem, RAM capture, because we're trying to get information within RAM, because as we know, the volatility, right, it's going to change as we go because this is on and operational. Now, more tools to utilize. Well, we talk about the use of volatility, recall, and what we're really wanting to do is being able just to analyze and extract that data. Each tool is going to have its special features that it can be utilized, like Linux, for instance, specifically for Linux machines. And you have volatility as well too, because it can work within different platforms. But the main case is being able to take this information, use these tools to get, again, a better picture of the processes that are running and the threads and handles that are running as well. Because we want to see if there are hidden processes running. We want to see if there's duplicate PIDs, or such can. I'll get more into that later on. But we want to make sure that we can understand what the process is. Are there any child processes that are running? What is that parent-child relationship like as well? And like, for instance, the example here is spawning the command line. It can initiate the child process to start. While you're not necessarily looking at the child processes, it's good to do so. You want to be able to detect malware. As we know, DLL injection, dynamic link library, is the ability to inject some malicious link. And we know computers are accessing our dynamic link libraries for information. Being able to use volatility to find these different injection attacks, or at least I would want to say more so the code itself. It can help us validate against something that's a known malicious file, a certain pattern, if you will, or known hashes that are potentially malicious. Now we want to be able to, again, we'll talk more in depth on some of the other aspects of like networking when it comes to the forensics piece. But we know that memory is going to preserve the live network connections. You can use all the different types of commands that's going to give you the information as far as like what's actually running. But we need that information, especially if that malicious file is contacting the C2, right? Command and control. So having network information as artifacts is very crucial. The routing table. Has there been anything added? Static, dynamically, right? Have we been able to see and peer into the packet captures within Wireshark? And then the use of recovering credentials and encryption keys as well too. So memory forensics, you don't necessarily have to use the traditional ways anymore, because you can capture clear text passwords. You can extract RSA keys using John the Ripper as one for password cracking, and then for key recovery, because our encryption keys, right? We can utilize memory parsing tools that allow us to do that. Now, what are some of the anti-forensic techniques that affect memory? Well, memory corruption. An attacker can overwrite a portion of memory, and that's essentially what happens in like buffer overflow attacks. But you can have self-destructing code. You can have obfuscation techniques as well too. You want to encrypt the running processes so that way it doesn't look, well, malicious or suspicious, because you can't technically see it. So understanding that there are techniques that are put into place to thwart some of the forensic techniques, they're there, but as long as we know about it, it's better for us to at least have that implemented. One of our examples here is going to be investigating banking Trojan. So as we know, a Trojan is a certain type of malicious code that says it's legitimate process, file, executable, right? But in our scenario, we have a banking Trojan that's intercepting browser sessions. Well, and it hides only in memory, similar to like a fileless attack. But the steps, well, we want to examine the browser memory dumps for injected libraries, right? Where it's hiding. Right? It has certain injections in place. We want to be able to trace the network route. Again, you can use tools. I know pfSense as far as like firewalls within the Linux systems can work. You can also just look at the route itself as well too. Now, when you're looking to create or at least establish a toolkit, if you will, for something like this, you want to have these tools in place that allow you to peer into that network. But the outcome is going to be, how can I see malicious attacks, components of it? How can I understand what this Trojan or who this Trojan is talking to? Well, that's why we go a little bit more into the network logs and go more into network forensics. And we'll talk about that in one of our other modules. Again, it's been great. Gennaro, CEO of Cortex Solutions here. And we just talked about memory forensics brought to you by ACSMI. I hope you have a great one. Take care.